Imagine, if you can, a realm beyond darkness, beyond light, beyond even time itself. This was the true nothingness, a perfect void. No space, no matter, no energy. Just an absolute, serene non-existence, a boundless canvas awaiting its first stroke. Yet, within this ultimate stillness, a whisper of potential, an unimaginable possibility began to stir on the very edge of reality. Quantum mechanics suggests even nothing is teeming with fleeting virtual particles, constantly popping in and out of existence, a cosmic foam. One such fleeting anomaly, perhaps a peculiar quantum fluctuation, instead of vanishing, lingered a fraction of a moment too long. An infinitesimal, energetic ripple, a silent vibration, then echoed through the boundless emptiness, a subtle yet profoundly felt precursor. This tiny, seemingly insignificant energy, liberated from the void, then began to curiously fold back upon itself, compelled by an unknown force. It converged rapidly, intensifying beyond measure, collapsing inward into an infinitely dense, incredibly hot, and singular point of origin. A cosmic egg, smaller than an atom, yet containing the entire universe's future within its nascent core. A point of unimaginable tension. Time, as we comprehended, hadn't yet begun. There was only this infinitely compressed potential, silent, waiting, inevitably. Then, in an instant beyond comprehension, the universe's expansion began. Not an explosion, but a rapid, colossal inflation. Blinding light flooded the nascent cosmos. Pure energy, raw and untamed, erupting violently in the universe's first furious birth cry. From this turbulent, primordial soup, fundamental particles materialized. Quarks, leptons, antiparticles, forming the universe's basic alphabet. The infant universe expanded exponentially, cooling dramatically, forging the very fabric of space and time from its expanding essence. Gravity, electromagnetism, strong and weak nuclear forces, the four fundamental architects of everything, now precisely took their distinct forms. Over unimaginable eons, these forces began to sculpt cooling gas and dust into the first swirling proto-galaxies, the initial great structures. From that solitary, infinitesimal point, an entire cosmos, teeming with countless stars and wonders, began its grand, unending journey. Yet the most profound question continues to echo: how did nothing, the absolute void, possess the inherent ability to ignite everything? The answer, perhaps, lies not in what nothing was, but in what it could be. A profound emptiness, yes, yet one brimming with latent possibilities, waiting for the spark. Before the Big Bang, there wasn't nothing as we comprehended, but a state of absolute potentiality. An undifferentiated, primordial ground zero, pregnant with creation. Imagine a perfect quantum vacuum, not truly empty, but teeming with ephemeral quantum fields, constantly fluctuating, appearing and disappearing in an instant. These weren't random occurrences, but fundamental properties of the universe's inherent fabric, even before that fabric itself truly coalesced and existed. A tiny, almost imperceptible ripple, a chance quantum fluctuation in this pre-cosmic soup was all it truly took. A momentary imbalance in the perfect symmetry. True nothingness, it seems, is inherently unstable. It simply cannot perpetually maintain its perfect, featureless, and utterly uniform state. From this infinitesimal imbalance, a singularity emerged. A point of infinite density and temperature, beyond human comprehension or scale. It wasn't something in an existing space. Rather, it was the precursor to all space, all time, all matter, and all energy. For an instant, or perhaps an eternity, everything that would ever be was packed into a volume smaller than an infinitesimal atom. Then, the Big Bang ignited. Not an explosion into a pre-existing void, but an expansion of space itself, carrying everything within its embrace. In the first tiny fractions of a second, the universe inflated at an unimaginable rate, smoothing out imperfections and laying the essential groundwork for cosmic structure. Energy was paramount, a roiling, seething soup of fundamental forces still unified, barely distinguishable from one another in the extreme heat. As it expanded and cooled, this raw primordial energy began to condense. E equals mc squared, the ultimate cosmic alchemist, turning pure energy into palpable matter. Quarks and leptons, the fundamental building blocks of everything, emerge from the inferno, zipping through the nascent, expanding universe. The universe was still too hot, too dense for anything truly complex to form. It remained a glowing plasma ocean, utterly opaque to light. But as millennia passed, the relentless cooling continued. Electrons finally linked with nuclei, forming the first, simplest atoms, hydrogen and helium. Suddenly, light could travel freely across the cosmos. The universe became transparent, revealing a vast, dark canvas dotted with the faint afterglow of creation. This was the very dawn of everything we know. A universe born from nothing, driven by fundamental laws, now poised to weave galaxies, stars, and perhaps consciousness itself. In the immediate aftermath of the Big Bang, space stretched, a rapid inflation cooling the primordial soup dramatically. This wasn't merely expansion, it was the birth of cosmic vastness, an almost unfathomable increase in scale. From a state of unimaginable energy, fundamental forces began to differentiate. Gravity, electromagnetism, and the strong and weak nuclear forces emerged, each carving its distinct role in the universe's unfolding drama. Quarks and leptons, the universe's most elementary building blocks, danced in a superheated plasma. Too hot for stable structures, they existed in a chaotic, energetic ballet, a true testament to raw cosmic power. As temperatures continued to drop, a pivotal moment arrived. Quarks coalesced. Protons and neutrons, the nuclei of future atoms, began to solidify from the subatomic maelstrom, marking a new phase of organization. For hundreds of thousands of years, the universe remained an opaque fog. Light couldn't travel freely. It was constantly scattered by free electrons, making the cosmos a dark, unseeable expanse. Then, at approximately 380,000 years old, a monumental transition occurred. The universe had cooled sufficiently for electrons to finally bind with protons and neutrons, forming the first stable atoms, hydrogen and helium. Recombination was the universe's first great illumination. Light, now free to travel, streamed across the cosmos, leaving an indelible imprint that we detect today as the cosmic microwave background radiation. But this newfound transparency heralded an era of profound darkness. With no stars yet to ignite, the universe entered its dark ages, a vast, silent expanse devoid of visible light, an immense cosmic void. Yet, even in this profound darkness, the seeds of future brilliance were stirring. Imperceptible density fluctuations, echoes from the inflationary epoch, began their slow, gravitational ballet, subtly drawing matter together. Over millions of years, gravity patiently sculpted the invisible. Hydrogen and helium atoms, though seemingly sparse, were inexorably pulled into denser pockets,
gradually overcoming the outward pressure of expansion. These growing clumps weren't yet stars, but proto-galaxies, colossal clouds of gas and dark matter. They were the nascent cradles where the first celestial giants would ultimately be born, grand cosmic nurseries. Inside these behemoths, the pressure and temperature at their cores reached critical thresholds. The relentless squeeze of gravity ignited the first thermonuclear reactions, shattering the cosmic darkness forever. These were the universe's first stars, known as Population 3 stars. Monstrously large, hundreds of times the mass of our Sun, they burned intensely, living fast and dying young, but illuminating the nascent cosmos. Their fierce ultraviolet radiation began to re-ionize the universe, stripping electrons from surrounding neutral hydrogen atoms. This era, called the Epoch of Re-ionization, transformed the cosmos from opaque to transparent. The lives of these first stars were spectacular but brief. In violent supernovae, they collapsed and exploded, scattering their precious, newly forged elements across the interstellar medium, seeding the universe. Within their fiery hearts, these Population 3 stars had fused lighter elements into heavier ones: carbon, oxygen, nitrogen, and iron. These were the very building blocks for future planets, for life itself. With each supernova, the cosmic palette grew richer. The pristine hydrogen and helium-dominated universe was now infused with the raw materials necessary for complexity, a galactic generational shift. This elemental legacy laid the groundwork for the next generation of stars and galaxies, a cosmic cycle of birth, death, and rebirth. The universe was still young, but the blueprint for everything was now in place.